Hi guys, welcome back. We ended our previous discussion with an interesting observation or discovery. We discovered that from the gradient formula, we can actually come up with an equation of a line that passes through point D. Okay? And this is really what we discovered. We discovered that the equation of a line that passes through point D, which is this line segment, by the way, is in this manner. And I said, we are now going to talk about these little things that are in this equation, okay? So far, we know that this thing here is our gradient M, okay? So what is this thing here? What about this thing here? What does it represent? Well, if we were to continue with the straight line up, okay, then this thing is telling us something, that this line, if we were to go up with it, it is actually going to reach at some point, a point on the y-axis. Here's the y-axis. And if you round this off to nicely to decimal, this is 20.2. So it is telling us that actually somewhere on the y-axis, this line will pass here, okay? As a matter of fact, it's a surety. This line here that passes through point D is going to cross through point 20.2. And this is the point actually where x will be 0. This is what, guys, is commonly known as the Y-intercept. Okay. And in the same sense, we can actually get the x-intercept. We can actually go down here and find out what is that number on the x-axis, which this line will touch on when y is 0. Okay, so in other words, we can just put this thing to be 0. If we want to find out that point, we can put this thing to be 0 and say minus 3 over 5 xd plus 101 all over 5, and then we have 3 over 5, that is 101 over 5. And then I'm just going to take a reciprocal of this thing on both sides. See that? This goes away. And then what is that x value? It is actually 101 divided by 3. And this is 33. That x value is 33.7. And this, fellows, is what we call the x-intercept. So there's a very interesting observation that comes out. From this, I want us to establish then a general formula for the equation of a straight line or equation of a line segment. In general, a line segment has an equation in the form y is equal to mx plus q, actually plus or minus. Okay, if even for m we can say, actually let me not confuse you, let me not say that, because you guys know if m is negative, then we're gonna get this kind of line. Okay, m negative, and another way to say m is negative is to say m less than 0. Here we know m is positive, so another way to say m is positive is to say m is greater than 0. That comes right from your number line. You know you have 0. To the right, you have positive numbers. To the left, you have negative numbers. Okay, so that's where it comes from. I just thought I should put that in for clarity. Okay, so we now know the equation of this line will be that, and that of that line will be that. Okay, we'll have the same formation, just taking note of the sign of m. So you may ask yourself a question, but what about these two lines here? One has a gradient of 0, one has an undefined gradient. Okay, well, let's work out this one. Here we said the gradient is 0 plus q. So that means this, the equation of this line is just y equals to q. That's it. Okay. What is y? What is q? I said q is the y-intercept. In other words, you're gonna look at this line and see where it intercepts with the y-axis. There it is, 10. So therefore, the equation of this line is y equals to 10. That's it. Nothing much, nothing to be stressed about. What about this equation here? Well, when it comes to this equation, we said there wasn't actually a change in x, so we could not divide by 0. So let's see what is happening here. Mx plus c or q, okay? I prefer using q. Some use c. It is quite known for that, but you'll see why I use q. Because I still use that when I talk about functions, you know, parabola, hyperbola, and all that. I still use q. I still stick to q, very consistent. So they use any variable really to represent the y-intercept. So don't worry. So what about this line here? Okay, well, let's use the same concept that we borrowed here, because we don't know what m is. M here is undefined. And what is if you multiply something by something, and we really don't know what the answer is. Okay, so we're not gonna bother ourselves very much by trying to see how can this go and all that. Okay, because we don't know the m here is undefined. Okay, what is undefined multiplied by something? I don't know. It is undefined, maybe. Yeah. So we're going to use the same concept. Here we said, well, actually, if you go through here, you realize that you're going to get, well, the line y equals to 10. That's what you concluded at. So we can actually use the same concept and say, okay, let's see. This thing is parallel to the y-axis, so it cuts the x-axis somewhere, and it is at the line x equals to 5. So conclusion, if you've got a line parallel to the x-axis, then the equation is going to be y equals to the value of the intercept, of the y-intercept to be particular. That's it. It's a constant. Actually, y is a constant. We can even say k instead of q. It's up to you. In terms of a line that is parallel to the y-axis, the equation is just going to be x equals to some constant also. Okay? That's just one fine thing that I want you guys to get. So we have learned about collinear points will have the same gradient, okay? Points on the same line will have the same gradient. We have two line segments kind of here. We have like segment DL and we have segment LE, and we expect them to have the same gradient, okay? In the next video, I'm going to expand this concept a little bit further. We're going to look at the gradient of lines that intersect at certain angles, okay? So to say, or lines that don't even intersect. So tune in as we continue to explore this concept of the gradient. Cheers.